Good evening, everybody. Thanks for coming out to Pints of Science. I see you've got a pint, you've got a pint, I've got the science. Let's get started. My name is Victoria, and I'm an ecosystem ecologist at NC State. Today I'm going to talk to you about nutrient cycling in ecosystems, but more importantly, what role large animals, or as we like to call them, megafauna, play in nutrient distribution across landscapes. What is nutrient cycling? Well, it's generally defined as the use, movement, and recycling of nutrients in the environment. So basically how nutrients like carbon, phosphorus, sulfur, all of the macro and micronutrients necessary to sustain life move through phases, from being locked up in rock, weathered by rain, and transpired into the atmosphere and back down, and every phase in between. We tend to think of nutrient cycling primarily in this way, driven by abiotic factors. But what role do animals play in the movement of nutrients through ecosystems? Let's think about it this way. You're drinking a beer, and we all know you probably already broke the seal. Now, beer isn't super nutritious, but it's got a little potassium, it's got a little bit of magnesium. You're drinking your 1, maybe 2, maybe 3, 4, I don't judge, pints of beer, and you're taking in all those nutrients. Then when the night is over, you're all gonna drive home to your respective places of dwelling, and you're gonna distribute all that potassium and all that magnesium in said beer across the greater Raleigh area. Basically, the distribution of nutrients by megafauna can be thought of in exactly the same way, except for over much greater distances and with more important nutrients that are often in short supply. Phosphorus, for example, is a very important nutrient for plant growth, but it's often locked up in sediment at the bottom of the ocean. How can nutrients like phosphorus, important to crops that we eat, get from the bottom of the ocean to the corn belt in the middle of the continent? The answer? Large animals. Recent literature suggests that large animals in particular drive nutrient movement. For example, marine mammals such as whales are able to move nutrients from the deep sea to the ocean's surface by feeding at the bottom and excreting at the top. This is what brings the nutrients from below to plants like algae at the water's surface. Seabirds and anadromous fish, or fish that live in salt water and spawn in fresh water, then eat this algae, or eat fish that eat this algae, and they transport those nutrients from the ocean to coastal regions. This moves the nutrients they take in with them from the ocean to land system. And once that phosphorus is literally dumped on land, it supports plant growth there, and is then taken up by animals that move it into the continental interior. To recap, nutrients can be moved both vertically in our oceans and horizontally across landscapes by animals. And in addition to that, animals cause these nutrients to be cycled much more rapidly than they would otherwise through the process of digestion. We're just beginning to understand how animals are important to these larger processes that we too rely on. This is important to think about because animal populations are dwindling. Many scientists say that we're in the midst of the 6th mass extinction. Because of this, animal ability to take part in these natural cycling processes is dwindling too. Gaining a broader understanding of the environment, its processes, and the other organisms that are involved in it allows us to make more conscientious decisions moving forward in our ever-changing world.